Good evening, everyone. Today, first of all, I just want to give my introduction. I'm Vinita Kaushik, and I'm an assistant professor in Maharaja Agrasen University from CSE department. Today, I will tell you something about the models in software engineering. Before go ahead, first of all, you have to know that what is the software engineering. Software engineering is basically a process in which we can develop any software with the help of the different phases. First of all, whenever we may have to develop any software, there are lots of models by which we can develop the software. In the short form, software development life cycle, we call that SDLC. SDLC is a spiritual model used in project management that defines the stages include in an information system development projects. There are different software development life cycles, models specified and designed, which are followed during the software development phases. These models are also called software development process phases. Each process model follows a series of phases unique to its type to ensure success in the step of software development. First of all, here is a diagram in which there are lots of types of models in software engineering. Basically, first model is waterfall model, then RAD, spiral, V model, incremental model, agile, iterative, and Big Bang model. Waterfall model is the basic model for the software engineering. In this method, the whole process of software development is divided into various phases. The waterfall model is a continuous software development model in which development is seen as following downwards, like waterfall. Clear? Through the steps of the requirements, analysis, design, implementation, testing, integration, and maintenance as well. The ordering of these activities has some significant consequences. First of all, we have to identify the end of the phase and the beginning of the next phase. Some certification techniques have to be employed at the end of each step. Some verification and validation usually do this mean that will ensure that output of the stage is consistent with its input, and the output of the stage is consistent with the overall requirements of the system. Second model is the spiral model. In this model, it was initially proposed by the Bohem as an evolutionary software process model that couples the iterative features of prototyping with the controlled and systematic aspects of the linear sequential model. It implements the potential for rapid development of new versions of the software. Using the spiral model, the software is developed in a series of incremental releases. Here is the diagram of the software spiral model. There are basically 4 types of phases in this. First of all, the progress, then product development, next phase planning, and the last one is the reviews. In this, lots of steps are there. First of all, management, prototypes, design, coding, integration, testing, implementation, and then at last, whenever we develop any software, we have to review that software. That what is the software we have developed, what is the consequences are there, what are the errors are there. We have to find out all of these things. These are the objective settings. In the each cycle in the spiral starts with the identification of purpose. For that cycle, the various alternatives that are possible for achieving the targets, risk assessment and the reduction. The next phase in the cycle is to calculate these various alternatives based on the goal and constraints. Development and validation. The next phase is to develop the strategies that resolve uncertainties and the risk. Planning. Finally, the next step is plan. The project is reviewed and the choice made whether to continue the further period of the spiral. If it is determined to keep, plans are drawn up for the next step of the project. The risk-driven feature of the spiral model is to accommodate any mixture of a specification-oriented. An essential element of the model is that each period of the spiral is completed by the review that includes all the products developed during that cycle, including plans for the next cycle. The spiral model works for the development as well as the enhancement of the projects. The agile model. The meaning of the agile is a swift or versatile. Agile model is a basic model for which is used in various companies, industries, And it is the basic and it is the advanced model. You can say that agile method breaks tasks into smaller iterations, but parts do not directly involve long-term planning. In this agile model, we can directly accommodate, directly communicate with the customer, right? And plans regarding the number of iteration, the duration, and the scope of each iteration are clearly defined in advance. This is the diagram in which agile model is working. First of all, design, documentation, iteration, demo, and feedback, iteration, quality assurance, then the deployment and the brainstorm. This is the agile model. Next is a COCOMO model. COCOMO model is the full form is a constructive cost estimation model. It was developed in the 1981 and it is one of the most generally used software estimation model. Where we have to estimate any model, then we have to use the COCOMO model which was developed in 1981. There are basically necessary steps in this model. Get an initial estimate. First of all, whenever we have to develop any software, then we have to take the estimate of any software, which we have to take some source code, like determine a set of 15 multiplying factors from various attributes of the project. Calculate the effort estimate by multiplying the initial estimate which all the multiplied factors. According to Beham, software cost estimation should be done through the three stages. First of all, basic model, intermediate, and the detailed. Basically, COCOMO model is divided into the three parts: basic, intermediate, and the detailed. This is the basic COCOMO model. The basic model provides an accuracy, the size of the project parameters. The following expressions are there, where KLOC is the estimated size of the software product. Whatever the product we have developed, that KLOC will determine the estimate size of the software in kilo lines of the code. Matlab, how many lines are there in the coding, right? Obviously, whenever we have to develop any software, when we are going to develop any software, then we have to programming for it. So how many lines are there in the coding of the software? A1, A2, B1, B2 are the constant for each group of the software product. T day is the estimated time, T for time here. And effort is the total effort required to develop the software product. This is a diagram in which we can estimate the software of the COCOMO model. It is effort versus product size. How many effort we are giving to the development of any software? It will be like organic, semi-detached, and the embedded, right? Next is the development time versus product size. इसमें क्या होता है कि whenever we have to calculate the KLOC is the how many lines we are using in the coding. This is the diagram in which nominal development time and the development time versus size. कितना हमें एक product को डेवलप करने के लिए टाइम लगा और उसमें हमने कितने टाइम में हमने कितनी कोडिंग करी और हमारा जो सॉफ्टवेयर का साइज आया कि हाउ मेनी लाइंस, हाउ मेनी LOCs we are using to develop the software, then we will calculate the size of the software. Organic, semi-detached, and the embedded. It is very important to note that effort and the duration estimation obtained using the COCOMO model are called nominal effort estimates and the nominal duration estimate. How many duration is there to do the development of any software? How much efforts we are using to develop any software? This will depend upon the estimation technique. The term nominal implies that if anyone tries to complete the project in a time shorter than estimated duration, then the cost will increase drastically. मतलब कि अगर हमने किसी को time दिया है कि you have to complete that software within the 10 days and we will complete that software within a 5 days, then the cost of the software will increasing. But if anyone completes the project over a longer period of the time, then estimated, then there is almost no decrease in the estimated time. The basic COCOMO model considers that efforts is only a function of the number of lines of code and some constant calculated according to the various software systems. The intermediate COCOMO model recognizes these facts and defines the initial estimates obtained through the basic COCOMO model by using a set of 15 cost drivers based on the various attributes of the software engineering. Classification of the cost drivers: product attributes, hardware attributes, personal attributes, and the project attributes. These are the attributes which are used in the cost drivers. The last is the detailed COCOMO model incorporates all the qualities of the standard version with an assessment of the cost drivers, effects on each method of the software engineering process. The detailed model use various efforts multiply for each cost driver properties. Next, the planning and requirements, system structure, complete structure, module code and test, and integration test, and cost constructive model. Thank you so much for this PPT and good luck.